Up until now, as we've been going in and talking about our markets, what we've been really caring about more than anything is that when market conditions change, what has been going in and happening to equilibrium price and equilibrium quantity. Has that value been going up or going down? We really haven't cared about the value of it. And so, what we've been doing up until now in our supply and demand curves is just simply marking our price with a P naught and then going in and marking our quantity with a Q naught. But the question has to be asked in the real world, how do we exactly know what our equilibrium price and our equilibrium quantity actually is? Is this something that is just observed, or can we actually go in and somehow or another figure out what the actual quantity for those variables actually are? And it turns out by going in and doing a little math on these, we can actually figure out precisely what the equilibrium price and equilibrium quantity is. So, what we will do is when you go in and you look at the demand curve, you can go in and you can gather data on the price and quantity demanded, plug that information into your handy dandy statistical program, and actually come up with an equation for your demand curve. Let's say in this particular case, the quantity demanded is going to be 300 minus 50p. So we can go in and we can plug a price in that is prevailing at the time, multiply it by 50, subtract that from 300, and that will give us what our quantity demanded actually is. We can do exactly the same thing with the supply curve. We can go out, we can gather data on price and quantity supplied, plug that into our computer, and it will go in and spit out an equation of the quantity supplied is equal to, let's say, negative 100 plus 150p. All right, so we are going to assume that we can go in and those values, those equations will always be given to you. But if you look at this closely enough, we have just a little bit of a problem because we have two equations, right, for the demand curve and the supply curve. But we also have more unknowns than we have equations. So in other words, quantity demanded is one unknown, quantity supplied is the second unknown, and since the price doesn't have any sort of subscript on it, it's the same price, so there is our third variable. Either way, we have two equations and three unknowns, and if you'll remember from your basic algebra class, you can't solve that. We have a problem. But it turns out we are going to be using an identity that we learned very early on when we were talking about equilibrium, and that is in equilibrium, the quantity demanded is always going to be equal to the quantity that is being supplied. So we are going to use that identity to go in and set these equations equal to each other and go in and solve for our equilibrium. So in this case then, our quantity demanded, which is going to be this part right here, so we're going to have 300 minus 50p. We're going to set that equal to the quantity supplied, which is this part right here. So we'll substitute in a negative 100 plus 150p. Now that solves our problem because now we have one equation and we have one unknown, which is going to be your price. And that's what we're going to be solving for. Now, for those of you who are comfortable with algebra, you know there are about three ways that you can solve this equation. For those of you who are not, I'm going to be going in and doing it just one specific way, and it's the way that I have found that you don't have to deal with a lot of negative numbers, so it makes it a little bit easier to work with. All right, and I'm going to be doing it the same way so you can follow along. I'm not skipping all over the place. So first of all, I'm going to move my p's over to the right-hand side. So since this is a negative 50p, I'm going to go in and do the opposite, and I'm going to add 50p's to both sides. All right, so negative 50p plus 50p is 0. So that leaves you with simply 300 on the left-hand side. Just go ahead and bring that right on down. We haven't done anything with this either, so we're going to bring this down as well. So we have a negative 100. And then if you add 150p's to another 50p's, then you get a positive 200p's that come out of that. So 150 plus 50 gives you 200p. All right, so now we've got our p's together. Now we need to go in and get this constant of 100 to the other side. So if it's a negative 100, I'm going to go in and do the opposite. I'm going to add 100 to both sides. So negative 100 plus 100, that is 0. And on the left-hand side, you have 300 plus 100, which is going to give you 400. And then go ahead and bring this right on down because we haven't done anything with that. All right. Now that we want to go in, we want to get the p by itself. You always go in and divide both sides by the number that is in front of the p. We call it the coefficient. Whatever number that is, you divide both sides by it. So you notice on the left-hand side, 400 divided by 200 is going to be 2, is going to be equal to, now be careful with this, a lot of people want this to cancel out, but this is now a division. So remember, 200 divided by 200 is 1. So you get 1p, or just the price, and that is our equilibrium price. All right, now, since this is a price, I'm always going to round it to 2 decimal places, so our equilibrium price is going to be $2 per unit. Okay, so there's our equilibrium price. Now that we have that, we have to figure out, well, what is our equilibrium quantity? So what I'm going to do is I'm going to take this equilibrium price and I'm going to plug it back into either the supply or our demand curve. It's going to turn out, in this case, I'm going to do both of them to prove to you that quantity demanded and quantity supplied come out to be equal to each other. All right, so let's go in and let's do our quantity demanded first. So our equation for our demand curve is going to be 300 minus 50p. Well, now that I know what p is, I'm going to go ahead and substitute in for p of $2. So you have 300 minus 50 times p, which is now $2. All right, solve it out. So we have 300 minus 50 times 2 is going to give you 100. So our quantity that is demanded is going to be 300 minus 100, which is going to be 200 units of the good. Okay, now if we've done everything right, that number is going to be exactly equal to our supply curve, which is the quantity supplied is going to be equal to a negative 100 plus 150p. All right, again, you substitute your p into that. So we have negative 100 plus 150 times the price, which is now going to be $2. Go ahead and simplify it. So you have a negative 100. 150 times 2 is going to give you 300. So our quantity supplied is going to be negative 100 plus 300, which is going to give us 200 units of the good. So there is our quantity demanded being equal to our quantity being supplied. All right. Now, the very last step in any one of these is to graph this particular market. So, to do that, just like you've done before, draw yourself a supply and demand diagram. Always mark your axis with a Q and a P. Draw a downward sloping demand curve. Always mark it with a D. An upward sloping supply curve. Always mark it with an S. All right, so up until now, all we've been doing is going in and marking this as our equilibrium price P naught. We now know what that is. That is now $2. So go ahead and put that on your axis. We now know what the equilibrium quantity is, and that's going to be 200 units of the good. This is a very specific graph of this supply and demand analysis. Okay, so there's the very basic way, and they're all done exactly the same way. The only difference is, and I want you to notice that in this particular case, we came out with some very nice even numbers. $2 for the price, 200 units for the quantity, and sometimes that is not always the case. So I want to go in and I want to do one more example for you, showing you how to go in and how to deal with the decimals. All right. So let's say again, we go out, we do our market research, and we come up with our equation for our demand curve, QD, and let's say that happens to be 80 minus 4P. Again, the supply and demand curves will always be given to you. Let's say the equation for our supply curve, QS, is going to be equal to negative 20 plus 8P. All right. Again, the first thing you do is go in and set your quantity demanded equal to your quantity being supplied. So substitute your 80 minus 4P into the left-hand side is equal to your quantity supplied, which is negative 20 plus 8P. And now we have everything in terms of P, one equation, and now we can go in and we can solve for our price. Again, I always move my P's first. So if it's a negative 4P on the left, I'm going to do the opposite, and I'm going to add 4P to both sides. So that goes in, negative 4P plus 4P, that is 0. And then you go ahead and bring down your 80, because we haven't done anything with that yet, is equal to, drop down your negative 20, because we haven't done anything with that yet. And then you add these two terms together. So 8P plus 4P is going to give you a positive 12P. So you add your coefficients and attach the variable. All right, so far so good. Now we have to get the constants over on one side. So if it's a negative 20, I'm going to do the opposite, and I'm going to add 20 to both sides. By doing that, negative 20 plus 20 is 0. So 80 plus 20 is going to give me 100 on the left-hand side. And then go ahead and bring your positive 12P down, because we haven't done anything with that. All right. Now remember, I said whatever number is in front of the P, you divide both sides by that number. In this case, that number is 12. And again, remember, 12 divided by 12 is 1. So you get 1P on the left-hand side, or just P. And then on the right-hand side, you're going to come up with, now if you plug this into your calculator, 100 divided by 12, you're going to get a decimal of 0.3333 repeating. So remember, since this is a price, it is a dollars and cents problem, so you always want to go in and round to the second decimal. So your equilibrium price then is going to be $8.33 for the good. All right, so there's your equilibrium price. So now we simply need to go in and solve for our equilibrium quantity. So to do that, I'm going to plug it into either one or both of the formulas. I'm going to plug it into the quantity demanded is equal to 80 minus 4p. Again, we now know the p is going to be your $8.33. So let's substitute that in. So our quantity demanded will be equal to 80 minus 4 times the price, which is $8.33. Okay, then we can go in, we can start doing the rest, simplifying it. So we have 80 minus, you have 4 times the quantity, 8.33, which is going to give you 33.32. And then, if you take your 80 minus your 33.32, that is going to give you 46.68 units of the good. Now, a lot of people will go in and ask, well, what do you do with that 0.68 units? Does that make any sense? And the answer is actually yes, it does. Because remember, I didn't tell you exactly what it was that we were dealing with. So we could be dealing with pounds, we could be dealing with ounces, or with feet, or with yards, or with tons. So that would make perfectly good sense, putting it in that form. So the last part is to go in and graph this very specific looking market. So we have quantity and price. We have our downward sloping demand curve, mark it with a D. Our upward sloping supply curve, always mark it with an S. Now we know exactly in this market what our equilibrium price is. So our P naught is going to be $8.33. And we know our equilibrium quantity is going to be 46.68 units of the good. And that gives us our very specific looking market.